So welcome to another video. So this is a very important topic whenever you are solving the physics problems, especially in mechanics, in JEE advanced. Most like in JEE mains, I don't think we will need that much, but in advanced you will have a very vast application of these polar coordinates. Okay, so especially in rotation, in circular motion, and also it will make your problems to do easier, but you have to understand this very well. So let us start. So we have a particle. This is a particle. So this is moving along this curve. Okay, and this is some angle theta, and this is the its initial position. So this is the xy coordinate, right? This is the xy coordinate system, and this is two xy coordinate system. This is also j cap. Okay, let me write like this: j cap. This is I cap. But what we'll do, like, if at this point, this is the r vector, okay, the radius vector, like the position vector here, this is the position vector, and here I am defining it as the radius vector or the position vector, whatever you want to define it as. And so I will define two new directions. Okay, so it is moving along this curve. So what I will have, along this r vector I will have a r cap direction, and perpendicular to that, if this is the r cap, perpendicular to that I will define another direction which will be known as theta cap. Okay, so I will define this as r cap, and this I will define as perpendicular to this one as theta cap. So what does these two mean? Okay, so this is the direction of radial vector. Okay, and this is the direction of the transverse. We can call it the transverse direction, like whenever it is traveling, if it comes at a point, this one. So here too I will have a theta cap here and an r cap here. It will be changed obviously, but I will have all along this curve. So I will try to derive the relation between this and this and these two directions. Okay, so I can define it as like this. This is the j cap, this is I cap. Okay, and this angle is theta. So what can I write? Okay, first of all I can write like this: if this, I put a perpendicular here, so this is what, if the magnitude, let us define the magnitude as r, so this will be r sin theta and this will be r cos theta. Okay, so what I can write this r vector as r cos theta I cap plus r sin theta j cap. Okay, if I take the r common, this is cos theta I cap plus sin theta j cap, and this is a unit vector, this is a unit vector. So also this theta vector, I want to define this theta vector to take theta cap. If I want to define theta cap, what will be? So let us write like this. So this angle is theta, this is 90 minus theta, and these two is again perpendicular, so this is theta. So I can see that if I consider this, so this is a unit vector, so its magnitude is 1, so 1 cos theta, if I put like this, 1 cos theta will be cos theta itself. Yeah. So I can write like along this j cap direction I have cos theta j cap, and along this direction, that is the x-axis, I will have minus sin theta, so this is in this direction, so I am having minus sin theta I cap. So this is my theta cap, and okay, fine, and this is the direction. Okay, so what will I, if I define this theta vector as, let it have magnitude theta and theta cap. Okay, so this will be my theta vector, and this is the r. So this is one thing you can notice it, that if this is a unit vector, if I consider this as a unit vector, if I consider this as a unit vector, so what will be this will be sin theta and this will be cos theta. So cos theta I cap plus sin theta j cap, so that will be my r cap. So that is what I have written here. This is my r cap, so I can rewrite it as r cap. Okay, this is my r vector. So I have defined two new directions. Okay, so what we know, if what is velocity? So first of all, let us derive the velocity in polar coordinates. Velocity in polar coordinates. Okay, so v bar because of r and theta. Okay, so this will be dr vector by dt. Okay, so this will be my velocity in polar coordinates, dr, that is the r changing of how my position vector changes, that will with respect to time will give me the velocity. So I have written like this. So d by dt of r cap, so this will be dr by dt, dr by, or I can write it as r, or to remember it, r dot r cap plus r dr cap by dt. Okay, so what is this dr cap by dt? So let us calculate this dr cap by dt separately. So I have r cap equals to cos theta I cap plus sin theta j cap. So dr cap by dt equals to, first of all, theta is also a variable, so first of all I will differentiate it with respect to theta. So cos theta will be minus sin theta into d theta. Now as per this product rule of differentiation, if I have this as a variable, we will first differentiate this one as with respect to theta and then theta with respect to time. Okay, by product rule. So this will be d theta by dt I cap plus sin theta will be cos theta into d theta by dt j cap. So if I take d theta by dt common, so I will have minus sin theta I cap plus cos theta j cap. This will be d theta by dt. Okay, so remember one thing, this d theta, this theta is of magnitude. Okay, so okay, so I have dr cap by dt. Now a very important observation is, you can see this one is written here too. What is this? This is theta cap. So I am getting theta cap. So I can write it as theta cap d theta by dt, or d theta by dt, theta cap. Okay, so I can write it as d theta by dt theta cap, or theta dot theta cap. So r dot r cap dot this one. Okay, so this one I can directly replace it here. So r dot r cap plus r in place of this theta dot theta cap. Okay, so this is my velocity vector. So let us highlight it. This is my velocity vector in terms of polar coordinates. Okay, so I'll give you a very easy trick to remember this one is, so if you want to remember this formula, you will need it later also. So you can remember it as double r plus r double theta. What is double theta? Theta dot theta cap double r dot r cap. So you can remember it as v bar, or velocity vector, equals to double r plus r double theta. So this is a easier way, and you can also prepare your own kind of, or the way of remembering this one, and also you can derive this. So what is along this theta cap, whatever velocity will have a velocity, right? So we can write it as Vt or V transverse, and along this radial direction I'll have radial velocity, and we can write it as Vr. So see, now I have this one, so from here I can say V bar equals to, or velocity equals to, r dot. So this is the r cap. Okay, this is the in the radial direction. So what is this one? What is this one? This term is my radial velocity, and this term is the magnitude. This term is my transverse velocity. Okay, so what can I write? Shit, what got removed? So I can write the velocity as V r cap, or the radial velocity in the direction of radial direction, plus V transverse theta cap, okay, in transverse direction. And what will Vr equals to r dot, that is dr by dt. This is magnitude, okay, like I am differentiating the magnitude of this radial vector with respect to time. And V transverse equals to r theta dot. V transverse equals to r theta dot. So this is my radial velocity, okay, and this is my transverse velocity. Also from here, from this one you can also derive another common inference, that is Vt equals to r theta dot. So what is this? R d theta by dt. And what is change of theta with respect to time? So d theta by dt with this one is my omega, or the angular velocity, right? So can I write V transverse equals to r theta dot equals to r omega? Okay, so if you have ever read the circular motion earlier, so you will know that the radial, or sorry, the transverse velocity is equal to r omega, or omega cross r. So this is a very important inference from it. Okay, so I have the velocity. Now I'll derive the acceleration. So this is a general plane motion. Okay, in case of any curve anywhere you can apply this one. Also if it is a straight line motion, obviously you are not going to apply that, but even if it is some general curve, so this will be a very important aspect, a very important concept of solving the problem. Okay, so let us calculate the acceleration in polar coordinates. So what will be the acceleration in polar coordinates? So acceleration vector equals to dv by dt. Okay, and what is dv? So d by dt of r double r dot r cap. Sorry, I myself forgot. R dot r cap. Sorry, r dot r cap plus r theta dot theta cap. So differentiating this, so I'll get d. So first of all, d by dt of r dot r cap plus d by dt of r theta dot theta cap. So d r dot by dt, so this one by product rule, so this one be r dot, so r double dot r cap plus r dot dr cap by dt plus, so I have three terms here. Okay, so one by one I will do this. R dot theta cap plus r theta dot theta cap plus r theta dot d theta cap by dt. So if I can group this once. Okay, so this is again you are getting this term. Okay, so what was this term? This one term was theta cap, theta dot theta cap. From here, see this one, theta dot theta cap. So I can write it theta dot theta cap. So r double dot r cap plus r dot theta cap plus r dot theta cap plus r theta double dot theta cap plus r theta dot. Now what is d theta cap by dt? So let us calculate this d theta cap by dt. So what is theta cap? Theta cap was this one, So d theta cap by dt was cos theta I cap plus minus sin theta. Sorry, theta. This will be minus again, minus, and this will be minus sin theta j cap and d theta by dt. Okay, so and also from here I can write minus theta dot this will be plus, so cos theta I cap plus sin theta j cap equals to r cap. Okay, so I can write it as r cap, and this is okay, this I have already written. So this is minus theta dot r cap. Okay, I've written correctly. So this is minus r minus theta dot r cap, minus theta dot r cap. So I can write it as r double dot r cap plus 2r dot theta cap. Okay, so I have three terms. Oh, sorry. This is another one. R theta dot theta cap plus. So here I have r theta dot and d theta cap by dt was this one minus theta dot r cap. So if I can group this r cap and theta cap together, r double dot, this will be minus r theta dot square r cap plus r theta double dot plus 2r dot theta cap. Okay, so this is it. So this is my acceleration vector. So let us write it clearly. Copy. So this one is my acceleration. Now I will tell you a very important inference, or you can say a very good explanation of these terms individually, which you will need in circular motion, in rotational motion. You will understand it later. So for now, what is r theta r dot dot equals to d square r by dt square. So what is this? This is the acceleration in the radial direction, or I can say radial acceleration. What is this term? This is minus r omega square. What is omega? Theta dot or d theta by dt. So this is r omega square. So this is another one. So this is at times you can say as this is the sorry, I have explained it wrong. This is not. This is the actually the translation or the acceleration along this radial path. Okay, so this is another translation along r. Here what acceleration will have? This one, and this is the centrifugal or centripetal acceleration, or you can say it as radial acceleration. And this is in the direction of radial, so these two are radial. What is this one? R alpha, because alpha is theta dot dot. What is alpha? This is the angular acceleration, and this term is a very new term to you, I think so. If you have read earlier, so it is okay. So for those who don't know, this is the Coriolis acceleration 2 r dot theta dot. So what it means or what physical significance does it have, we'll learn it later when we study rotational and circular motion. For now we can remember that this is the acceleration in polar coordinates. So that is for today. Subscribe for more interesting content regarding the physics. I'm trying to bring more and more problems, more and more topics which are often misunderstood, and students often find it hard to understand. So I'll be here to clear all your doubts, and if you have any doubt, you can ask me in the comment section. and to connect me with Instagram I have given the link. Okay, so that's it for today.